Hey guys, I'm Juliet and this is my lab report for Lab 1. For this lab, we were to demonstrate the concept of constant velocity. So when an object travels the same distance every second, it is said to be moving with constant velocity. And we were to demonstrate our knowledge of this by filming the motion of an object of our choice, traveling the same speed and without changing direction. So for our first three lectures, we have been learning about Newton's first, second, and third laws and the momentum principle. And so this lab allows us to understand the application of these laws in the real world, but also see how often objects do not travel at exactly constant velocity. We are interested in seeing how these objects resemble the natural way that they should behave, described by these laws, but also understanding that it's not going to be exact. For my lab, I chose to roll a 16.9 fluid ounce full water bottle on a wood floor. I then used Tracker to extract the object's position with the corresponding time in order to get a model for observed position versus time. To get this data, I indicated the center of mass within every frame, which had a set time interval. After that, I used a computational model by using Python code and GlowScript that accurately described the observations I found based on the momentum principle and Newton's second law to create the predicted position versus time model. So for the prediction model, we had to assume the initial conditions of position and velocity both starting at zero, as well as net forces all equaling zero. And then we applied the momentum principle to get that final velocity equals initial velocity plus the net force of the ball over the ball's mass times the change in time. And the position of the ball equals the initial position plus the ball's velocity times the change in time. So Newton's first law of motion says that any object moving at a constant velocity has no external forces acting upon it, which would mean that the sum of the forces acting on the object must equal zero. And for this lab, we were trying to create an example of this and move an object at a constant velocity. However, the main fundamental principle that we demonstrated in this lab was Newton's second law, or the momentum principle. The second law states that the acceleration of an object is dependent upon two variables, the net force acting on the object and the mass of the object. So if the forces are balanced, an object at rest should stay at rest, and an object in motion will stay in motion with the same speed and direction. For our lab, the force of our object should be balanced and depend on the mass and the acceleration of our object. Objects with a heavier mass will have larger forces, and similarly, the momentum of our object is proportional to the mass times the velocity of the object. So if the mass and the velocity of the object are constant, the momentum of our object should also be constant. So the main goal of this lab was to compare the results of our observed model, which came from the experiment we put on in using Tracker, versus the data and results from the predicted model, which we used GlowScript and coded something for. So it is important to understand that for our computational model, we had to set all of the net forces to zero, as would be true for an object traveling at constant velocity. But because of the external forces and human error in our physical experiment, we did not have a net force of precisely zero, and that is the main reason why the data between the two models is different. So we can see this in my line graph because the slope of the predicted position versus time graph is constant, which indicates a constant velocity, but the line itself for the observed position versus time graph is not straight, which indicates that the water bottle wasn't moving at exactly a constant velocity. And this could be due to multiple external forces or human errors. So the first one would be the fact that I did not indicate precisely the right center of mass of my water bottle in each frame. There could have also have been friction on the floor that was starting to slow down my object. There could have been gravitational or drag forces. Also, for the interval that I chose, the water bottle still could have been speeding up at the beginning from my initial push to get it started. There could have been a slant or an uphill of the floor that may have caused the water bottle to accelerate or slow down, or the object just was not moving at a constant velocity. So changing the orientation of the axes would only change the direction of your position vector, going from either the positive to the negative x direction. It would not change the velocity vector or any numerical values, just the sign in front of the value. And no, there is no way to measure exactly how many or what forces are acting on our system in the observed experiment, We can assume possible external forces like pushes or pulls that act on our object, but we have no way of knowing how many and if they balance out or if the net forces equal zero.